some of the things like Z plus for these all harmonic searches where you just have lots of jets and missing the T. This is a nightmare. One of the nightmares you have is Z decaying into neutrinos, which gives missing the T, and then jets. And Z plus jets is not very well understood theoretically, so you should deduce it from the data. So one way how to do it is essentially take the Z to mu and just take the mu's away, because then you artificially generate missing the T. That's fine, but you only have a factor of 6. You have a factor of 6 more new final state than you have muons, so you are statistically limited. You can leverage the W and replace W against the Z. You have 10 times more W's, that's fine, but then you have, of course, also larger backgrounds from QCD and mismeasure missing energy. Or you can do photon-less jets, which is large statistics, but then you have to propagate their in tree level a similar diagram, but then there are other diagrams which are not in the Z plus jets, and you have to correct for that as well. But the nice thing is you have several methods, and you can leverage against each other these 3 methods to measure this. Okay, let me just skip this, is a rather technical one, so let me for the last 5 minutes just go to this slide. So supersymmetry, as you know, has many incarnations, so there's a little Venn diagram here where you have, let's even start with the other stuff. Let's start with the MSSM, which has about 105 parameters, and then you can make various assumptions to put them together. Phenomenological MSSM has 19 to 24, and then the constrained MSSM, which was formerly called MSUBRA, has 5 parameters. And you can have, for a typical constrained MSSM scenario, you have these cascade decays I described, and then lots of parameters to choose from. You also know from Slava's lecture that the intimate relationship between Mr. Higgs and Mrs. Susie in terms of the hierarchy problem. I stole this slide from him in the lecture, but I found it so beautiful. This is that they're actually sort of entangled with each other. You know that the supersymmetric particles should help regularize the radiative corrections of the Higgs. And in turn then, for them, you can actually get from the observation of a standard model like Higgs, which is also the lowest lying Higgs state for supersymmetry, you can then also cut into SUSY space, because as you know, supersymmetry has one prediction that the lowest lying standard model like particle should be below 135, but now we have actual observation, and then we see that certain models such as GMSP and AMSP are already excluded just by the very fact that we have an Higgs boson observation, provided of course it's the lowest lying state, and we haven't missed the lowest lying one. This is maybe the A or the large H. So what we do in